right, thank you. I'd like to start by saying I used to think that CSS is easy. Well, that was because when I started, I didn't really care about the code quality. All I had to care about was just to hack a design out and make it look nice, make it look visually appealing, and then I'm done for the day. I don't really care about the code, right? Then somehow, somewhere along the way, I started to care because I wanted to be a good front-end developer. So I started asking a lot of questions. Like, is my CSS good enough? Am I doing the right things? Am I using the best practices? These are all questions that you probably have asked yourselves as well. And the list goes on. Is my CSS maintainable? Is it dry? Dry enough, maybe? Is it scalable? Is there anything I can improve on? And if there is something I could improve on, how can I do it? So armed with these questions, I sought out an expert. That's my expert. And that's probably what you use as well. So when I went on Google, I wanted to search for what other people were doing, how other people were writing their code. And I wanted to imitate them as much as I can. Because in my mind, I wasn't a good front-end developer, at least not enough yet. I wanted to find out what they were doing so I could copy and make myself much, much better. The good news is I got some answers. The bad news is I got too many answers. And I started even asking even more questions. So questions like, what framework should I use? Should I use Bootstrap? Should I use Foundation? Should I use some other nameless framework that you never heard of? Then somewhere along the way, I'm like, maybe I shouldn't use Bootstrap or Foundation because it's kind of sucky in a way. I have to overwrite stuff too much. So maybe I shouldn't use frameworks after all. Then I started Googling again, and then I found this like CSS, BAM, SMAX, Atomic Design, and all the other kind of methodologies. And the question comes, and then there was, which one should I use? Is it possible to use all of them at once, or is it only possible to use one of them? If so, which one? So the questions I had go on, and that never answered my main question that was at the start. And that was how to create maintainable, scalable websites with maintainable, scalable, clean websites. I just didn't have a clue at that time. And then after a long time of struggling, Googling, hacking on my own, banging against the wall, I found some answers. And I'm happy to be here today to share what I think is good with you. Before I move on, let me tell you a little bit more about myself. I'm Zell. That's a picture of me playing in the desert. I like my scarf. I'm a freelance designer and developer from Singapore, and when I'm not designing or coding, I am teaching people how to do front-end development. What a hobby, right? So what I did, mostly through my courses and blogs, that's where I teach front-end development. And once in a while, I do workshops like yesterday's and conference talks like this one. So far, I had the privilege to help over 30,000 readers a month right now. But that's the end of me. Let's go back to the topic. And that is, how do you build maintainable, scalable websites with clean CSS? So, like I was saying, it took me a long time to figure out how to even begin doing that. And the main reason was because I didn't know what the hell was wrong with my code in the first place. So when I began Googling, I tried to take different bits and pieces and plug it into my code directly. And that was like taking a square peg and fitting it into a round hole, because that wasn't workable, because I didn't even know what was wrong in the first place. So what I did was to dig deep into my own code, and I realized how to become better along the way. So let me show you with an example with my simple blog up there, what I think needs to go into a responsive website. Yeah, back to the topic. So if you resize my blog down a little bit, you'll see this breakpoint where the font size of the body text changes. Then you also notice that the font size of all the other components change at the same time. While the font size changes, the paddings and the button sizes, they all change slightly, but they are all proportional to the change in the font size. When you build things for your website, you want to think about how your components change with one another. Do they change equally? Do they change proportionally? Or do they not change proportionally? So these are some things you want to take note of. let's put this under the name, let's call this proportional scaling for now, because the changes are proportional. Then if you resize further, you come across this breakpoint where suddenly things just, it snaps. The layout's changed, the font size changes again, the proportion between the header font sizes and the body text font sizes also change. So when you think about building your components, you need to think about what kind of breakpoints are there. At each breakpoint, do one component change? Do many components change? Do one change affect another change or not? So let's call that responsive scaling and put it under that title. Now, if you dig a bit further, you'll see that some things can be used in multiple places. For example, like the button over here that is used in the article archives. Then it can also be used in a form. It looks exactly like the same as the button. So it's kind of like a Lego block where you can move around, right? And then it looks exactly the same over here as it is over here. But if you notice between these two, look at the input elements. It looks about the same, but it's slightly different. The label is about the same, but it's slightly different, right? So when you build components, you want to think about them like Lego blocks. Like, can you take one thing, put more blocks onto them, make them into a bigger one, and then use this one smaller block or a compounded block into your website? So how do you stack things together, split things apart, and gel them together? Right? That's the Lego. Let's call that modular scaling. So essentially, you need to take note of three things: proportional scaling, responsive scaling, and modular scaling. If you go into the first thing on proportional scaling, we need to take note of what your component scales its property to. So for the example of a button, it can scale according to its own font size. So if you change the padding a little bit, if you change the font size a little bit, the padding should automatically change. To build such a component, you need to use relative units like EM, CH, or percentages. Which one you use is really up to you. The main idea here is to use relative units. And to create a button like what I had earlier, all you had to do was to add padding in EM. You can also add the font size in EM as well. Once you do that, you can scale your button proportionally all the way until infinity if you want to. Like Buzz Lightyear, if you remember, he was saying, to infinity and beyond. Okay, but anyway, you don't need so many buttons on your site. You probably need 2 or 3 sizes. To do so, you could group the common properties into a single class selector and add modifiers around. So button would contain all the properties of the button that you need. Then change a few things in the button small, like font size, and it should scale accordingly. And change a few things in button large, and it should scale accordingly. All right? And in your HTML, it will look somewhat like this, with a main button class and a button large class, which is the modifier that you have given it. If you use CSS, which is my ideal approach, you use a mix-in to contain the common styles. Then you include that button in your modifier. In this case, you can use 1 class instead of 2 in your HTML. It's my preferred method because I like to keep my HTML as clean as possible as well. So now we talk about component scaling according to their font size. They can also scale according to the viewport. If you scale according to the viewport, you need to use viewport units like VW, VH, Vmin, and Vmax. Here's an example of a rectangle that is always 1/4 of the screen size. Very simple example. So if I resize the browser, it is always going to be 1/4 of the size, no matter I do vertically or horizontally. Another example would be combining typography with viewports, and that is coined the term fluid typography. When I resize the browser, you notice that the font sizes change as well, directly, without the use of media queries. It kind of looks like this. You have to use calc with a EM or pixel value plus a viewport value, and for the rest of your stuff, you style according to EM. For more, I'm not going to talk more about the fluid typography, but if you like more, you can read the article. I'll put the slides up. Read this article by Mike Rielf-Meller. I hope I'm not butchering his name. So anyway, when it comes to proportional scaling, you want to scale you want to know what property you want to scale to. In CSS, there are only two things to take note of, and that is font size and viewport sizes. If you want to scale according to the font size, you need to use a relative unit like EM. If you want to scale according to viewport, you need to use a relative unit like VW. Refrain from using pixels as much as possible because that is not scalable. All right? Now, once you have built a few smaller components here and there, you want to combine them like Lego blocks, kind of something like this, where you put everything together. And let's go into this methodology and how do you think about doing that in the first place, right? Lego, I like Lego. So if you think about Lego blocks, think of it like a block. I don't have a Lego here, but think of this as a Lego block, and you have another Lego block together. Each Lego block kind of has its own space. It should not protrude out into any additional areas. So just imagine if you have a button with an extra margin, like this is the extra margin, and you try to put it on top, below another Lego block, you have an extra margin. So what it means is when you put Lego blocks together, you have to make sure there are no extra spaces, so you can just combine things like that. But if you put things together, you need some sort of space in between, and that is the larger component that you're talking about. So the larger component needs to manage its internal white space, but each Lego block should not disturb the external white space. All right? So that is how this kind of looks like. Anybody coded something like this before where the top white space is different from the bottom white space? Show of hands. There we go, so many. What we do is, why this happens is because of this irritating margin at the bottom. So one thing we can do is to remove that margin bottom, and that is probably the first thing that we think of usually. And like what Chris Coyer mentioned, it's not really a good idea because you're fighting a losing battle if you go for margin bottom for every single last child element that you need, right? One better way to do so is to use the adjacent sibling selector. So let me just give you a very quick example. I hope you can see this. So there's this single component where we are talking about one Lego block by itself, and then multiple components where we stack multiple Lego blocks. Notice what happens when I add the adjacent sibling selector. So when you have an adjacent sibling selector, which means this block plus block over here, the single components would not be affected. What is affected is the subsequent components, like the second one, the third one, and the fourth one. So in this case, you can remove the bottom margin, and you get the spaces that you want. And you can, of course, change whatever you want to suit the white space that you require. So that is how adjacent sibling selectors can help you with writing better code, at least simpler code. This pattern is so widely used, I think, in my code that you might even want to try this lobotomized owl selector, which is coined by Hayden Pickering initially. I think it's a few years back. You can use it directly in the global, the first example over there. But that is a little bit harder to pull off for most of us if we have projects that are already ongoing. You can try doing that for new projects. If you want to use the star plus star selector for a local an ongoing project, you might want to localize it to, like, say, component, direct sibling, star plus star, something like that. Right. So we talked about managing the external white space outside and some of the internal white space. What happens if you try to put a margin of 1 EM, because white spaces are usually created with margin, on a button and put it this way? The problem is, if you scale the font size of the margin, take note of how if you scale the font size of a component, take note of how the margin changes at the same time. So it increases, right? What this means is you kind of have to create and recalculate properties in the large or small buttons, if you have them, to fit the fonts to fit the original margin that you wanted. That is not really nice. Luckily, CSS has this thing called rem, which is somewhat the same as EM, but it is relative to the root font size. So if you use, if the HTML has a font size of 16 pixels, one rem will always be 16 pixels. If the HTML has a font size of 20 pixels, one rem will always be 20 pixels. In this case, you can say font size of 2, 3, 4, 5, whatever rem, whatever M you want, and set margin top and bottom to 1 rem. In this case, no matter how you change the font size, the margin will stay the same. So let's take a look. Right? The margin stays the same no matter how the button size is increased. Now, to help make it simpler, you can think of M as a local variable and rem as a global variable. Global to the entire site design or local to the selector itself. The problem with thinking in such a way is that we as developers, we always have this mindset that a local variable is always good, but a global variable is bad. And that is what happens when we do too much JavaScript and all the other kind of development stuff. But in the case of design, are local variables really good? Are global variables really bad? In design, we want to make things consistent. And when we want to make things consistent, we need some sort of global. So I would ask you to rethink this notion of local is good, global is bad, especially when it comes to CSS and design. And just to quickly summarize Lego blocks, they should not disturb the surrounding white space, but they should manage its own internal white space. To help you do that, you can use adjacent sleeving selectors, and you can also use global and local variables like M and rem. Now with that, let's move on to the next thing, which is responsive scaling. Responsive scaling happens when you move to a certain breakpoint and suddenly everything changed, right? The whole idea here is to be able to write good media queries. Now, for our discussion, let's scope media queries down to min width and max width. Can I have a show of hands who uses min width queries predominantly? Okay, max width? What was the rest? You don't code? Okay, fine. Maybe it's just in the morning. But, all right, so there's a difference between using min width and max width media queries. Why is that the case? Consider we are trying to make a component, simple one, that changes from one font size of 1 EM to a font size of 2 EM at a certain breakpoint, whatever the breakpoint is. If you use min width media queries, you don't need to write the font size of 1 EM because that is the default, right? Then at a certain media query at a certain breakpoint, you put in your font size that you want to increase it to. So in this case, min width 37.5 EM, font size of 2 EM. If you write it the other way around on a max width media query, you kind of think desktop first. All right, the big size is 2 EM. I'm going to put it down. Then as I move it down towards a certain breakpoint, I have to change it to 1 EM. So that's the max width media query kind of thing mindset. But the problem here is you added an extra property and declaration that is already the default. So you just imagine with this very simple one font size example, you already have one extra line of code. What happens if you need to change the layout from just a normal display block to some fancy display grid stuff? You have a lot of lines of code to handle, and you need to reset everything. So min width media queries is always better than max width media queries by default. But that doesn't mean max width media queries are useless. You can use them as well to contain your style sheets to a specific viewport. Let me show you a very quick example. Let's imagine we are trying to build a component that is 3 by 3 square. At a small viewport, it is going to be blue in color for all the different squares. Then in a medium viewport, the alternate squares are colored red. On a large viewport, the first, fourth, and seventh squares are colored blue. The second, fifth, and eighth are colored red. And the third, sixth, and ninth are colored green. So let me quickly do a demo on this one. I hope this is okay. I should remove my current stuff just to mess with you. Right, so let's say we begin writing the code, right? Can everybody see? Is it big enough? Big enough? All right, cool. So my HTML is quite simple. It's 9 boxes straight inside a grid component. What happens is, what I did to set everything to blue is to add a background color of blue to all the grid items. Pretty simple. You probably wouldn't have a problem with this. At a certain min width, always use EM. I'm using pixels just to make the demo a little bit smoother. So in a min width of 600 pixels, I intend to set every second item to red. To do so, you can use the nth child even or 2n, whichever is up to you. Let's set it as even. And once you save and refresh, you can see that, hey, it's actually blue, red, blue, red, blue, red, blue, red. The problem really happens when we go to the large viewport. So let's go through how we can think about doing this. So at large viewport, we want the 2nd, 5th, and 8th to be red. That means we need to use an nth child of 3n plus 2, which means that. And the 3rd, 6th, and 9th to be green, so we do an nth child of 3n. So every 3rd item would be green. Now watch what happens when I save and refresh and drag out this viewport. It kind of works, but it doesn't, because we still have the red square over here. Can anyone tell me why? All right, talks. Nobody answers. Right, the main reason is because we had the background color red bleed from the medium viewport, bleed into the background color red of the large viewport. What many people would do here is to create a separate selector, like this, set it to 3n plus 1, which means the 1st, 4th, and 7th, set it to blue, and you get the answer that you originally wanted. But why are you trying to add an extra property that you have already declared somewhere else? And that is already the default that you are already using. So instead of doing this, what we can do is to limit the damage from the medium viewport with a max width media query. Something like this, and you get this as well. So this is what I mean by combining min width and max width. Oh shit. Now let me get back to where I was at. Media query. So just to sum off media query, you want to favor min width over max width as much as you can, but don't be afraid to use both min width and max width media queries if you need to. Next, let's move on to modular scaling, which is the third thing that we want to talk about today. We already talked about Legos, and that is the initial part of modular scaling where you have one thing, you're going to build into other components. But we have something else that we are still haven't talked about. So let's say, for example, I call this morphable components. So let's say, for example, you have 2 different components that should be almost exactly the same. In this case, we have the green button and the pink button. They look almost exactly the same, but when you use the green button in a certain place, it looks green. If you use the pink button in a certain place, it looks pink. So like green and pink. But it should be the same component, right? I mean, it's not too far off from each other. It kind of does somewhat the same thing. You would probably know how to code this thing out already, given what we have said so far and your previous experiences. So let's go into a more concrete example of how something like this would look like. So I chanced upon this page called Founder Mantras, when I was teaching someone to code front-end development, and that's, to me, the perfect example of a morphable component. So let me now open up Founder's Mantra. You can see that there's a single view and a grid view between the components. And if you look around, the single view and the grid view looks pretty much the same. right? In the single view, there is the quote. In the grid view, there's the quote as well. In the single view, there is the author. There's the author in the quote as well. It's styled a little bit differently, but let's put it at that first. The only difference here, the major difference here is that there's a date in the grid view, but there's no date in the single view. And obviously, they look different. One is much, much bigger than the other one. So the question then over here is, how do you build one component that allows you to morph from the single view to the grid view and back, just like that? To do so, you want to take you first want to take note of the similarities and differences, then create a best fit HTML, whatever you can think of. An example will be something similar to this, like quote with a message and an author and a date within it. Once you have this best fit HTML, you want to think about how do you modify your HTML such that if it's placed in a certain area, it changes the whole looks of it. One way to do so is to add it to the parent class. So in this case, there is single view or grid view, and there's a quote inside either single view or grid view. So if the quote is in the single view, it looks like the single view component. If the quote is in the grid view, it looks like the grid view component. Then the whole idea of creating the component is exactly the same as what you saw inside proportional scaling, where we created a button. You put the shared styles into the component itself, by itself first. Then you create like single view, which is the modifier, followed by all the stuff you need in the single view, then followed by all the stuff you need in the grid view. Pretty much like that. The second way of doing it is to change its own class instead of the parent's class. In this case, I added the quote -- single or quote -- grid to differentiate the classes. The CSS for these two things would look almost exactly the same. It's the same principle, so obviously it's the same. And once you created something like that, you can create a demo, which is that switches between the two very, very simply. So this is what it can look like. I switch between the single view and the grid view. And the only thing that changed in the HTML on how I did it was to change the class from single to grid and change it back to single. So with one change, with one modifier, you essentially switch the entire component around to a different look. And that is what you want to think about when you build components. So that is Founder's Mantra, but that component itself is very, very obvious to most of us when we sit here and we look, it's almost exactly the same. Look at this page instead. Can anyone tell me how many items are there? How many components which of the things can be built into one component? 3 items, right? So the first one inside the grid view, the second one in the list one, and the third one in the headlines. Why? Because there are a lot of similarities between these components. Well, there is an image for all 3 of them. There is a title text, which looks similar. It's all bold. The font size is the same. There is a background color, which is grayish. And when you hover on it, you can't see the hover here, obviously, but when you hover on it, it changes to a lighter background color, and that happens to all 3 of them. So these are some of the similarities that are within all 3 components. The major differences is, well, the other 2 components don't have the description or the paragraph text like the headlines. The other 2 components don't have the counters, like the 1, 2, 3, 4 list numbers in the list type. So those are smaller little differences that you can create with CSS. And obviously, you can change the layout of the component with CSS as well. So these 3 can be grouped into one component. So just a quick one, all 3 of them have this, 2 of them have this, and this is what that's different if you go into it. So then you already know how to build something like that. The question is, can you figure it out on your own and build it out? So it's a matter of trying it out then. Just to summarize this part off, for morphable components, you want to find the similarities and differences between the different views. Then you craft your best fit HTML as much as possible, and you modify the looks with CSS. As much as possible, you want to minimize the number of modifiers. Make it to 1 if you can. All right. And just before I end off and have a break, I would like to share with you some additional tips that I noticed that you could use. And the first one will be for naming components. It is very useful to use BEM. Like for example, in this case, a double dash signifies a modifier. This double dash is better than a single dash because it is too obvious that something is wrong when there's a double dash compared to a single dash, right? And then the double underscore signifies that the date is part of the code component. So it tells you that there is a parent-child relationship between components. If you don't know about BEM, I highly recommend you check it out and have a think through it. The second thing I would recommend is to use namespacing. So earlier I talked about Lego blocks, where you have small components making into big components, but the whole component kind of talk feels a little bit, it's just hard to explain to other people, especially when you look at the code. So one way to think about it is to define very small components, like call them maybe elements, atoms, whatever you want to call it, it's fine. And then these elements can group together to form components, something like that. In this case, elements should not disturb the external white space. Components may have its own layout for the internal stuff, for example. You may also want to use additional white spaces like layouts specifically to name layouts like L-article, states like is active, has sidebar open, things like that. And JavaScript to provide JavaScript functionality to the developers. So when you change the class of your component, it doesn't really break the JavaScript hooks. It also tells you that this component requires JavaScript to be used. Right? The third thing I would say is to learn to manage specificity. So you will need to know how specific something is. Like for example, class is in the ones place, tags are in the ones place, the classes are in the tens place, and ID is in the hundreds place. It is kind of misleading because it's not really 1, 10, and 100 because 1,000 classes cannot override a single ID. In that case, you will want to think about structuring your entire CSS file in such a way where tags come first because they are the lowest specificity. Then for each component, you can override them easily with classes. Right, so use classes over here. Then, as much as possible, do not use IDs in your CSS. You can still use them in HTML, you can still use them in JavaScript to create functionality, but don't use them in CSS because it creates spikes. And you need another ID at least to override another ID. But if you use classes, the relationship becomes much, much simpler. So stick with classes. And if there's a need to, you can always use utility classes with the important thing. Very rarely you use that to end off the specificity curve. With that, I have almost come to the end, so let me just quickly wrap up and say a few things. So building components that are modular scalable for a responsive website with clean CSS isn't rocket science. What we need to do is to look at the things that we have already built, figure out what is wrong with it, then find a way to correct that. No matter what you do outside and plug other people's experts' ideas or whatever, it doesn't really fit into your own methodology unless you make it fit by looking at what is really wrong. So you have to pick what is right for you and use what is right for you. With that, thank you. And I hope you have learned as much as I have had fun giving the talk.